Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P1898, indicates a problem with the CVT, Continuously Variable Transmission, system of a Honda Civic model from 2016 to 2021. Specifically, it points to either the CVT drive pulley pressure control valve being stuck in the on position or the CVT-driven pulley pressure control valve being stuck in the off position. These valves play a critical role in controlling the hydraulic pressure necessary for the proper function of the CVT. The pressure is controlled by the Transmission Control Module, TCM, which uses electrical signals to adjust the hydraulic pressure based on the current vehicle conditions. When these valves fail to operate as intended, the vehicle's transmission can exhibit improper shifting behavior, which may lead to significant drivetrain issues. Understanding the causes and symptoms related to this DTC is essential for effective troubleshooting and repair. DTC P1898 primarily concerns two components within the CVT system: the CVT drive pulley pressure control valve and the CVT-driven pulley pressure control valve. These valves manage hydraulic pressure, which is crucial for the operation of the CVT. Specifically, the CVT drive pulley pressure control valve regulates the pressure within the drive pulley assembly, while the driven pulley pressure control valve governs the pressure within the driven pulley assembly. Both valves have a direct impact on vehicle performance, affecting shifting efficiency and smoothness. These components are located near the transmission, typically integrated into the CVT assembly. Their proper functioning is vital for the seamless operation of the vehicle's transmission system, and any malfunction can lead to serious drivability concerns. The possible causes for DTC P1898 include two primary scenarios: the CVT drive pulley pressure control valve being stuck on, and the CVT-driven pulley pressure control valve being stuck off. When the drive pulley valve is stuck on, it can result in excessive hydraulic pressure, potentially leading to erratic shifting behaviors or overheating. Conversely, if the driven pulley valve is stuck off, the hydraulic pressure may drop too low, causing inadequate torque transfer and sluggish performance. Additionally, underlying electrical issues, such as a damaged wiring harness or faulty connectors, can interfere with the proper operation of these solenoids. These issues may compromise the electrical signals sent from the TCM, hindering the valve's ability to respond to the commands effectively. The symptoms associated with DTC P1898 may include erratic shifting of the transmission, where the vehicle may struggle to change gears smoothly. Drivers might notice the vehicle hesitating during acceleration or shifting unexpectedly. Additionally, the malfunction indicator lamp, or MIL, may illuminate, and the shift position indicator may blink, signaling a problem with the drivetrain. Poor acceleration or sluggish performance is another common symptom encountered, primarily due to inadequate hydraulic pressure resulting from the faulty valves. In some cases, the vehicle might also experience severe overheating or a noticeable decline in fuel efficiency, directly linked to improper transmission operation. The first step in troubleshooting DTC P1898 involves starting the engine of the Honda Civic. Once the engine is running, observe its initial functions and performance. This initial check is crucial as it sets the foundation for subsequent tests. Ensure the vehicle is in the D position or mode to simulate standard driving conditions. During this phase, look for any unusual sounds, vibrations, or alerts on the dashboard that could indicate further issues. This step gives a broad view of the vehicle's operational state and prepares it for further diagnostic procedures. Move to the second troubleshooting step by accelerating the vehicle to a speed of 37 miles per hour 60 kilometers per hour, while keeping it in the D position. This acceleration progress is significant as it simulates typical driving conditions that the TCM needs to monitor. At this speed, the TCM will assess the operation of both the drive and driven pulley control valves. Pay careful attention to the vehicle's response. Any irregularities may serve as initial indicators that there are issues with the valves or their control systems. This step is critical for capturing the behavior of the transmission under load and is designed to help isolate whether the solenoids are functioning correctly. In the third troubleshooting step, gradually slow down the vehicle to a complete stop after reaching the designated speed. Observing the transmission's performance during this deceleration is vital, as the vehicle should transition smoothly from acceleration to a halt without jerking or stalling. Any unusual behavior during this process may indicate complications in hydraulic pressure management within the CVT system. This observation allows you to understand better how the transmission responds to changes in speed and input commands, which are critical factors in assessing the solenoid valve's performance. Once the vehicle has come to a stop, the next step involves accelerating with wide open throttle. This test is essential, as it places the CVT under maximum load, which could help expose any latent issues. The intention here is to observe how the transmission responds to a significant demand for power. Listen for any unusual sounds or feel for any hesitations or jerks during acceleration, which may indicate a malfunctioning solenoid valve. Monitoring how quickly and smoothly the vehicle accelerates is crucial in understanding whether the hydraulic pressure is being managed effectively, allowing the transmission to perform optimally. Following the wide-open throttle acceleration, the next step is to slow down and stop the vehicle once more. This test is similar to the earlier stop. However, it allows for monitoring the CVT's performance after undergoing high-demand conditions. Checking for smoothness and responsiveness during this deceleration is critical, and any irregularities may point towards faults in the pressure control system. An evaluation at this stage can also provide insights into the solenoid's ability to react properly under different driving conditions, which is a vital aspect of the CVT's functionality. The sixth step involves turning the vehicle to the off-lock mode, which resets the transmission control system status. This action is necessary to initialize the system for a new diagnostic cycle. Ensure that all lights and indicators turn off, signaling that the system has reset. This step allows the TCM to reevaluate the transmission conditions without any residual fault codes potentially affecting the next test. Performing this reset is pivotal in ensuring accurate results during the diagnosis of the DTC P1898, as it establishes a clean slate for the next driving cycle. Finally, it is essential to repeat the driving pattern steps 1 through 5 to confirm whether the issues identified previously still persist. This repetition allows for a thorough verification of the symptoms associated with DTC P1898. If the same problems occur, the TCM will again log a confirmed DTC, further validating the diagnostics. Make sure to perform this repetition under safe traffic conditions, as real-world driving patterns are critical in diagnosing transmission issues. By repeating these steps, you can determine whether additional components may be influencing the solenoid valve's performance, or if the valves themselves should be investigated further. After completing any necessary repairs based on the diagnostics conducted for DTC P1898, it is essential to perform a final repair verification step. This involves evaluating the effectiveness of those repairs to ensure that the issue has been successfully resolved. Conducting a test drive is a crucial aspect of this verification, as it provides real-world conditions for assessing the new functionality of the CVT system. Monitor for any symptoms that might have been present prior to repair, such as erratic shifting or warning lights. Successful resolution will ideally result in smooth operation and no recurrence of the DTC. This verification phase is integral to ensure reliability and performance in the vehicle's drivetrain. Preventive maintenance is critical in minimizing the risk of DTC P1898 and other CVT-related issues. Regular checks of the CVT fluid should be performed to ensure that it remains clean and at optimal levels, as this directly affects the hydraulic pressure management in the transmission. Changing the CVT fluid at recommended intervals is also essential, as degraded fluid may lead to valve stickiness and overall transmission inefficiency. Furthermore, servicing the CVT valve components can help prevent premature wear and maintain their proper function. Ensuring that all electrical connections are secure and free from corrosion also supports the reliable operation of the solenoid valves. Implementing these preventive measures can significantly increase the longevity and performance of the vehicle's CVT system. In conclusion, addressing DTC P1898 involves understanding the symptoms and possible causes of this particular fault code, which primarily relates to the CVT drive and driven pulley pressure control valves. Following a structured troubleshooting approach enables technicians to pinpoint the issue accurately and implement effective repairs. Regular preventive maintenance is equally essential to mitigate the chances of this code reappearing and ensures the overall integrity of the vehicle's transmission system. By maintaining a proactive outlook toward both diagnostics and regular upkeep of the Honda Civics CVT system, vehicle owners can enhance performance, reliability, and drivability. Recognizing early symptoms and conducting thorough investigations will lead to timely resolutions, ensuring smooth operation of the drivetrain. Please like and subscribe to the channel. See you next time.